Okay.
All set.
Okay.
Okay.
뒤에 어림을 잘해가지고 그냥 겨울에도 잘 큰다고 했더니
아, 겨울에는 어디든지 잘 크지, 덥지 않으니까.
아니요 근데 진짜 이런 시간이 더니까 진짜 더덥더라고.
아이고, 잘 크는 거야. 저기, 그냥 수시만 크겠어요. 여기 눈치를 잘하지. 워낙 잘하셔가지고.
아이고 내가 우리 집이 뭐가 잘 커. 아니 여름에 이 정도면
Okay, looks familiar.
And then, so that's what this does. And it takes a picture every 10 seconds or so. So it's going to be timed.
어린이가 전통에 와가지고 이게 저기가 없어요. 뭐가 너무 우리 집에 잘 커서
Everything synchronized.
어디에서 그 시스템이 잘 내신 것 같은데. 그 남편이, 그 남편이 용사꾼 아니에요? 뭐 해야 되는 뭐다 해준다고.
뭐다 해주고 다 잘 큰다고 그냥 하는데 잘 크더라고 가보니까.
Okay.
Okay.
This is Carl Purnell and John Ferrazzo doing a personal planetarium.
Oh, great. Good morning.
부치가 그렇게 많은데도
Should I refer to you as, what do you call the teacher?
달라고 그럴까봐 뭐라고
Huh?
That's all right.
We have to acknowledge you so everyone knows who's instructor.
We're both learning from each other.
Okay.
I got a clipboard I can use.
Okay.
You remember when there was always something in the cereal box?
Yeah.
You go, always something. Well now, yeah?
Yeah.
Now it's the box itself.
Yeah.
So we're going to make this planetarium from the box itself.
Uh-huh.
But we need a few little details.
Okay.
Why was this important? Well, you know, I used to work nights, and I said, well, that's a planet. And I didn't know what planet it was. So I made this discs, so I would know what planets are in the sky at what time. But those planets, you know, they move. They were never quite in the sky at the same place, same time. So I needed a way to set the clock. I call it the, I don't know, solar system clock or something. Well, it's just a planetarium. It's just a personal planetarium. So I discovered the U.S. Navy Astronomical Applications Department has its division called Data Services. And they can give, for Las Vegas, where the Sun, Venus, Mars, Jupiter, Saturn, Moon are at any given time.
And they got the latitude and the longitude.
Right. The right ascension and declination. Where are you going to see it in the sky?
Right. Okay.
Yeah? Well, this is 2015. That's a little old. We got something a little newer.
You know, my background, I worked for 5 years at the Hydrographic Office,
Uh-huh.
Pearl Harbor on Nimitz Island.
Right.
And we used to service all military. Military, they'd come in and service, and we also sold to merchant marines or what have you. And then on every chart, you would put what the update was, and notice to mariners. So if a ship, let's say, going to Guam or what have you, you hold the charts for them. They'd tell you where they're going, and then they would say, the next thing they'd say, what's the latest update, or what's the latest notice to mariner. And and you tell them, and then you'd say, when you get to Guam or the entrance buoy, the light has changed the frequency,
Oh,
and in other words, that light, every now and then they would change the frequency.
huh.
So other ships that did not know, the skipper could pull out his Notice the Mariner or something like that, and when we're coming in to port, if we all knew, but if somebody didn't know, they would know that that's so-and-so beacon and Barbara's Point,
Right, right.
but they couldn't understand because of the signal it was sending out.
Right,
But the military, we always knew.
right.
So you knew if somebody was coming in there that shouldn't be,
Huh.
our Navy destroyers or something would be out there in a minute.
Yeah.
And they would request permission to board the ship.
Right, right.
And of course, that was a big joke because since when does a Navy destroyer tell another vessel request permission to board?
Well,
It was sort of customary,
sure.
but they would say, if they said, well, no, it's a wrong time or something like that. And pretty soon the riflemen or something like that say, no, this is the right time, everyone back off. They'd have everyone stand at attention, not at attention, but raise arms.
Right.
And it was sort of neat, scary but neat. But that's the way our military operated. We didn't ask permission for anything. We gave the orders, and
Yeah. Well,
and when you're passing a ship at sea, the first thing they would do is ship coming right away. I was a signalman and a
Right.
quartermaster. They'd say, quartermaster, ship coming up over the horizon. What is it? It's a USS O'Bannon. Regardless what, and they'd say, who's the officer? The senior officer. And you would have to tell him it's Captain so-and-so. And then right away, look him up. What's his date of rank? Because when you pass the ship at sea, as you're approaching, everyone stands at attention and salutes the other ship as they're coming by. But
Right.
the senior officer is the one that would stand there and they would salute him. And
so you had to know the rank, who was
know the
passing.
rank and date of rank, and right away you'd say O'Bannon, you'd look it up and say, oh, that's a Navy commander or so-and-so. What's his date of rank? And then big smile because the
You
captain
outranked.
say he outranks him and he's going to have to.
So who's you?
And as you're approaching, they got this loudspeaker like, attention on deck! And they all stand at attention, and we stand there and look. And then they salute the skipper, and we'd all make a joke about it later. And the skipper, are you happy now or something?
Well, my brother's asking if I'm home.
Where's your brother at?
He's out doing errands, so I need to tell him. We should be back.
He lives here in
Yeah.
Vegas.
We're over at Carl and Suni's now.
He knows who, and when you say Carl and Sonny, he knows who.
Knows your friends.
Yeah.
Filming.
내가 어떻게 하면 우리 장한
Filming.
편집할 때만 기다리는 거 아니야?
Filming.
좀 해달라고.
Personal Planetarium. Personal Planetarium.
그러니까 지금 이도 남자들 같은데
Filming the Personal Planetarium.
준비하는 거야. 두 개 다 거의 다 내 건데 하나를 비워줘야지 잔이 이제 쓰고 이제 해먹을 거 아니에요.
Alright, there it is.
지금 마시는 거야.
Okay.
Now
아 이게 뭐야 해먹든지
all kinds of videos.
내 생각이지.
I don't want to take everything out and then forget it and leave it at home. Okay, so
내가 한 번은 이제 우리 일하기 전에 자기네 집에 오면
So here's our data. Today's the 17th. I did it for the 17th.
Okay.
So here's our sky. It just so happens that this sun has all these little triangles. So all we need are 24. But I don't remember quite how many there are. So I'm going to use a pencil. I've got a pencil in here. I got everything in here.
그 집에 저기 내가 그때 일했대요. 자기가 뭘 해주냐서 내가 그래 오래간만에 스파게티 먹고 싶은데 그랬더니
Here's a pencil. So I'm going to start and number them so I know how many I have, so I know which ones to use. We start with 0, and then we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, that's 12, 1/4 of the way around.
Right.
So how many are going to be when you get back to the top?
How many what?
How many of these little triangles will we count if we count it all the way back to the middle, back to the top?
24, 36, 48.
48, 4 times 12.
Yeah.
Well, we only need half of that.
Half of that, 24.
So we're going to use every other one.
Okay.
So now I'm going to switch to a pen, then, and this becomes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that these are hidden. So we'll have to estimate where those are. But we know this is 24, so we go backwards. 23, 22, 21, 20, 19, 18, and these are, you know, like 180 degrees, or you know you're on the right track.
Okay.
If you get to the fourth mark, or the 1/4,
Right.
and you come up with that number, you know, okay, I'm counting correct, I didn't make a mistake. 18, 17, 16, so this will be 15, that's 14. But we'll have to estimate those when we need them. We don't know if we need them yet.
Okay.
So there's our 24-hour sky,
Wow.
or right ascension. So now we have our numbers. We're going to use the sun, Venus, Mars, just to show us how to do it. Now you can use Jupiter and Saturn, you just need a little more room. Maybe the moon, because the moon's, we're having an eclipse next Monday.
Yeah.
So that's just for today. So I'm going to use part of this paper here for scratch paper.
Are you going to be out there for the eclipse?
Well, I might be on the roof, but I have to work.
Oh.
And it's going to be like Idaho. And we didn't have any plans. We didn't do anything yet. All right, so we're going to write down Sun, Venus, Mars, and then we'll skip to the moon, just to get an idea where the moon is, where everything. So that's the object. Now we're going to do the right ascension, RA. Right? And so the sun is 9 hours, 46 minutes. We'll just use rounding up.
Okay.
Venus, now make sure you don't put down Mercury, because that's we're ignoring Mercury. I've seen Mercury once. It's just too small, too close to the sun.
Yeah.
I don't know. For me, it's just kind of a hassle.
Okay.
So Venus,
722.
there you go, 7:22. Mars,
가서 한 잔 마시고 한 잔을 갖고 왔는데
9. We'll go to 22 because it's 21:8.
Yeah.
And then Moon is 5:16. Well, that's nice if you know your minutes. But
뜨겁게 마시다가 이제
we have
안 마시고 싶으면은
we,
거기다 내가 넣고 싶은 거 다 녹아고
we're going to have to plot in between here.
커피숍 마실 거야.
And so I think it's easier to change this to a decimal.
근데 뭐 커피를 내가 뭐해서 마셔? 커피숍 마셔 그거 해다가
So
보면은 안 마셔가지고
to do that, I just put over here the decimal,
그렇게 되더라고요. 나는
the
그거
0.1, 0.2, 0.3, 0.4, 0.5, 6, 7, 8, 9.
거기까지 가는 시간이 그래서 많은 게
아니야.
And every 6 minutes is 1/10 of an hour.
Okay.
So we're going to go 6, 12, 18,
18.
4 times 6, 24, 30, 36, 42, 48, right?
48.
And 54, right?
Right.
9 times 6. So it's just a little, this is the minutes, and this is the decimal.
Okay.
Decimal of an hour. So now we're going to change it. 46 is going to be 9 point, it's kind of halfway between 7 and 8. Almost, a little closer to 8. We could go 8 to round it up.
Okay.
So we'll do 9.8. All right, 7:22. It's pretty close to 24. So we go 7.4 for an hour.
Okay.
9:22, same thing. 9.4. The moon 5:16, 17:18, 5.3. So we have a decimal for where we're going to plot it. So we're going to plot these along this circle.
Mm-hmm.
Now we need to know how far away they are. So we're going to use the distance. So we used object. Whoops. I got 6 days. I got the 11th, 13th, 15th, 17th, 19th, and 21st. If I didn't have the right day, I'd get all messed up.
Yeah.
So that we're doing the 17th. We did object, right ascension. We changed it to decimal. Not to be confused with declination.
Mm-hmm.
We're not using that. We're using distance. We're using distance here now. And these are in astronomical units, which is between the average distance between the Earth and the Sun is 1 astronomical unit.
Mm-hmm.
But this is all from the Earth now. This is all topocentric, how we look at it from the sky. So the Sun, which we expect to be 1.012. And then Venus is 1.253. We'll just write the whole thing down. Mars is 2.654. Now Moon isn't that. It's kilometers. We won't need to put that because we're not going to do the distance accurately. All right, so now we're going to plot these on our clock here.
Mm-hmm.
Right? So we're going to need a little. We're going to need. Where did I put it? Huh. Here it is. Going to need a ruler.
Okay.
Because we're going to have to measure distance. Kind of fall in right there. All right. So I'm going to use the millimeters because they're easy. You know, estimating between inches is just kind of hard, and millimeters it already counts it for you. So first we'll plot the sun. We'll go at 9.8 on the clock. We'll turn this over, and we come around 9.8, almost 10.
Mm-hmm.
So if we did, that would be 9.5, and then halfway between the 5 and the 10.
And being halfway.
Well, 9.8, almost. Here's some fruit.
Yeah.
Okay, take a bite.
우리 또 가게 갔다 올게요.
This is melon, some kind of melon.
1불짜리
Mm.
호박 많은 게 1불이에요.
Well,
너무 맛있는 거야.
아니 어느 가게인데?
it's too hard.
이거 소화제에
Come
하나
on, crunch it.
먹어. 이거
Do you want a napkin?
Mm.
Let me get you a napkin.
아, 먹어요.
Yeah.
누가 스탠다드 있어 올 테니 뭐.
Ah! We're gonna get a couple of napkins.
그래야지.
이거 미술 간다.
There we go.
너 나이 먹는데.
All right, so my estimate is that 9.8 is right about there.
Mm-hmm.
So now we need the middle of this circle. And we know the middle, you just go like from here to there. Somewhere in here is going to be the middle. Now we need one here. We can't go here because we don't know where there. We go 10 and 22. Those are opposite.
Mm-hmm.
We've got that one there, and then we just... So there's our middle.
Mm-hmm.
So now we're gonna go for the middle out here to 9.8. So the sun is along this line. But we're gonna use this line in another way, so we're gonna make it a little bit longer to the other side too. Because this is gonna be our axis. We'll see how that applies in a minute. Now we need to know how far out it is. And we said there's 1. Well, the biggest thing we're planning is Mars. So now we need to scale this to our drawing.
Mm-hmm.
So since Mars is like 2.5, let's see where we have about 10 centimeters.
Mm-hmm.
So if we let this one, Mars, be about 10, or 2.5 equals 10 AU 10 centimeters. Then we have a scale that we can plot these in a helpful way. This is where a calculator is helpful, but let's see what we can do anyways, because we'll show the calculations. So the sun, if it's 1.012 AU, then we're going to multiply by 10 and divide by 2.5,
Mm-hmm.
because that's our conversion. This is a little tricky, but once you get the hang of it, the units, the astronomical units, is like on the top of the fraction. So you're going to multiply that fraction by the astronomical units on the bottom. So those will divide out.
Mm-hmm.
So the centimeters is what we want to end up with. So that one's on the top, that's a multiplication. That one's on the bottom. So like A times B over C is going to give us B units. I don't know. I'm not the very good teacher, that's why I'm not in the classroom, I guess. But whatever the A units are, they put them on the bottom, you end up with B units.
At a board ship,
Yeah.
we'd be out there in a quartermaster, because every few hours he wanted to, they'd have what they call them DR, dead reckoning. We're on course 090. The speed, we're traveling at so many knots, but the skipper didn't want you to tell him we're approximately here, his answer was, we're right here,
Exactly.
right now. And it was strange, but what they would do, they'd go out and shoot the stars with the sextant. He'd take the sextant and he'd give you give you a figure,
Yeah.
and then they'd tell me, Carl, run down to Chart Depot and look it up. So I'd go down there and I would look up the figures he gave me and go to the almanac and get the latitude and the longitude and plot it on the chart and run back up there and say, here's where we are at,
0700.
yeah, 079.
All right, so my conversion said 4 centimeters on this scale. So I took the middle, I come out 4 centimeters, I make a mark, and I draw a circle around it for the sun. Because that's where the sun will be. Here's the Earth. On
Yeah.
this map, this is the Earth. Because we're all looking at it from the Earth side.
Right.
There we are. So now we do Venus. So like we did, you multiply by 10 and divide by 2.5. So you do 1.253 times 10. Oop, 1.253 times 10 and divide by 2.5. So this is going to be about 5 centimeters. All right, so let's do that. So we're at 7.4 on the clock and 5 centimeters out. So we'll come back here. 7.4 is almost 5, so we'll come back like to there.
Okay.
And we're going to come from the middle out. There's the middle. And there's the other one. Line them up, do 2-3 times so you get it right. This is definitely in this direction. So Venus is in that direction. But how far out? It's at 5 centimeters. So we look over here. Oop, that's inches. Here's centimeters. There's 5 centimeters. We'll make a mark. And this is Venus. Again, we'll make a little circle. Suppose you could do symbols, but I don't remember what symbols they are. So just do a symbol. We're right on this axis that this is Venus. Okay? Ready for Mars?
Yeah.
Okay, we do the same. 2.654 times 10 divided by 2.5 is about 10, which we expected, but not quite. 10.6. And since it's centimeters, we can do millimeters, so 10.6. So what's the clock say? Where is it? 9.4, kind of along the same line as the sun. So we'll come back here. Oh, I forgot. 9.4. So 9.4, just like the other one, we're going to 9.5. We're going to come back one. That's about 9.4. Go to the center. Go to this one. And your pen, kind of hold it against there. Come back. So this is Mars. That's the Mars axis. Okay, how far out? 10.6. We line this up here. 10.56. It's kind of right along in that same. Definitely, there's a lot of marks, so we make sure. So Mars is going to be in this position and out there. Now, wouldn't it be fun? Maybe we should know just. It won't be. Won't get the distance, but maybe we should know where the other two are. Now that we know how to do that.
Okay.
So let's just see where Jupiter is at 1313.
Okay.
So we know that that's about 13.2. So we'll say over here, 13.2. We won't worry about how far away it is, because it's far enough out. It's off the screen.
Mm-hmm.
So 13.2. Oh, it's down here now. Well, how are we going to know where those are? Well, we know where the middle is, and we know where 24 and 0 is. So we know this one, that's 12. And
Okay.
we know where 1 is, right?
Right.
We know where the middle is. There's the middle. So now we know where 13 is, which is right about between 13 and 14.
Mm-hmm.
And we need what, 13.2? Well, we're going to need to estimate. So we better get 14, and we're going to break it down in between that. We got 2, the middle, and that's going to be where 14 is. Now 13.2 would be, it's got about 23, so maybe 1, 4, maybe about there. So we could say with confidence that Jupiter is out in this direction.
Mm-hmm.
How far out? Well, long ways out. It's not going to change too much when we do our adjustment. Saturn's even further out, but it's at 1722. So that's like almost 24, which is 0.4. About 17.4. Well, that's over here, right? Almost 5. That's 0.4. Put that here. We say Saturn. Saturn's going to be, if we open this up, maybe Saturn will be over here somewhere. But we're only concerned with these 3 as far as, oh, where's the Earth? I know, it's a trick question. Remember, the Earth is in the middle,
Yeah.
because that's where we're looking from.
I was going to say, right here.
There you go. Right.
Okay.
No trick at all. So we have the Earth, the Sun, Mars, and Venus.
Okay.
Now watch this. So this is the wrapper that the cereal comes in. So you take that apart, carefully open it up. Now you got like Mylar. Remember they used to do maps in Mylar? And
Right.
so and now we're going to have to kick it up a notch because we need a marker. All right, where is it? Now this one's going to be tricky because we got to hold it steady while we make our marks here. It's a big one, but I couldn't find the little one when I left. So we're going to carefully mark the Earth, the Sun, Mars, and Venus.
Venus.
Right?
Okay.
Now watch this. We're going to let go. Now we're going to put the Sun in the middle, carefully sliding, and guess what? This is where the Earth is. Poke it hard. This is where the Sun is, we know that. This is where Venus is. And this is where Mars is. In a heliocentric solar system. We looked at it from the Earth, but now we just shifted the center of the system so we can see. I don't know if we can take it off. Let me just peek. Okay, I made enough of a dent, see, with the pen, and it's soft enough that we have. So this is Venus, this is Mars,
어떤 사람은 술 먹고
that's Earth, and that's Sun.
Okay.
So now we can set our clock.
그거 보니까
So this is Venus, and this is Earth, and that's Mars.
아니 뭐 내가 뭐 국장
Let's see, Venus, Venus is like 3.75. Put a B there. So if this is like the clock, now I did 12, like a normal hour on the clock.
Mm-hmm.
So 3.75 is almost like 2 o'clock. So we'll turn that to 2. So that'll be Venus. Earth is almost at 22, which would be like 11 o'clock. So holding Venus steady, then we move that one over. And Mars is over here. What did we say? Not off much from where it was. And it's about 9 o'clock.
Mm-hmm.
Well, divide by 2 is about 4:30. So we come over here, rotate Mars. It's the red one. Ha! About 4:30. Now Jupiter is the orange one. It's not going to change much off of this. It's about 6:30. So come over here, rotate that. Maybe we should set Saturn first. That's the harder one. Where's Saturn? Saturn is almost 9 o'clock. That's about where it was last time I set this. Maybe a little bit further. So what we have now are the relative positions of the planets that we can see around the sun.
Mm-hmm.
So we're here on Earth, and when we see the sun rise, it's rising now, we're going to see Venus first before the sunrise, because it's going to come up first. And maybe just before dawn we're going to see Mars. But we're not going to see Jupiter, because the sun's up. And we're not going to see Saturn, I don't think, because the sun's up. And then the sun goes down there. So now we can see Jupiter. It'll appear just after sunset. And now we can see Saturn, which will be maybe just before midnight. It'll rise. So you kind of you have the planetary rise and set times from this personal planetarium and this little toy.
Mm-hmm.
That's what I wanted to share.
Yeah. Amazing.
Yeah, I thought it was pretty cool. This sliding thing, where did I put it? This is the key to switching from the Earth as the center, which we know it's not the center of the solar system, but it's where we see things, to the sun being the center, and we just slide it along that axis. And this is now the gravitational center of the system that everything does rotate around. That this little shift is the miracle that made modern science say, you know, maybe we need to look and find out how this system really works.
Mm-hmm.
So I've been learning about systems, and I've been reading this little book, Thinking in Systems.
Mm-hmm.
a primer. Vanilla H. Meadows. And she was at MIT, and then they moved to Dartmouth. And she says that when we think in terms of systems, then we're seeing the interrelationship of the elements and their function as a part of the system. You look at a ship and the function of a destroyer as a function. And if you look at all the elements, they're according to that function. But if you take one of the elements out, you put him on dry land, you're not going to be able to see what that function of the ship is by looking at that element separate from on board. But if you see the quartermaster on deck signaling light, you see what he's doing, you can see, oh, maybe that's connected to the whole somehow. And if you see the destroyer in a fleet as a part of a navy, then it's perhaps following the function of the country that commissioned it and sent it on its mission.
Okay.
And so it's this system thinking that helps us to say, okay, what's happening, what's related. Now, is there any way to improve it without messing it up? And so she talks about some other systems that where the person makes an adjustment and it results in things going wild, unexpected, and that with a little practice and a little understanding, you can realize what adjustments that are going to be helpful to improve the system. I know I've had ideas, oh, we could improve this by doing this. And I have no idea how that unit or how that element relates to other elements, much less its function in the whole.
Yeah.
So I'm on the Senior Citizen Advisory Board, and I'm just trying to learn the parts of the system now and their interdependence, much less their function. Everything seems to be working great, but I don't know that because I haven't seen the whole system yet. I've looked at the voter registration rolls, and there was a law passed a couple of years ago that purged those rolls of people who hadn't voted. I can see the reason for that. You know, if they haven't voted, perhaps they passed away or perhaps they moved away. No reason to keep them on the rolls. But I'm wondering if there's senior citizens on there who just weren't able to get to the polls or something, and now they're off the rolls and they don't know it, and they don't know that they can't poll. But more than likely, there's an aging factor in that corrected.
Yeah.
But when I was doing the preliminary statistics, I found a guy who was 103 years old. When I looked at his name, he looked like the names of the other fellows, other people in the household, but instead of a W, it was an M in his name. So I thought that was suspicious. One, the 103, he seemed pretty old. We should celebrate his birth. But then when I looked at the last name, and everybody else had a W in their last name, and he had an M in his last name, and everything else was the same, I called my friend in the election board, and I said, what do you think about that? And he said, well, it looks pretty suspicious, but here's his voter registration card. I said, well, she says, I really don't deal with this, but I'll pass it up to the person who does. So they did, and the person who checked it over said, it's a typo. So they took him off the rolls. I don't imagine there's a lot of those things, but you don't know. And right now, those are the only data I have to learn about the senior citizens in my ward, because we're responsible. I'm assigned to Ward 5 in Las Vegas. And but the files are so big, I can't use them on my little computer. So I was looking for a computer I could use yesterday, maybe at the library, where you could download them and then get statistics off them. But again, you know, what's the purpose? What's the purpose of our board is to find out what concerns the senior citizens. And how are we going to know that unless we have communication with them?
Yeah.
And,
and who voted and who didn't, and why.
well, that might be helpful.
The why is probably the most important factor you have, because you want to know, as an analyst, why this person did not vote. Did he not vote because he's incapacitated and too old?
Yeah?
Had no way to get to the poll?
Excellent.
And, there's many factors that might give you that, but if you have that why, that's the most important thing, to know why John did not vote, without going to John to find out or embarrassing him
Oh, yeah, yeah,
in
yeah.
front of friends.
Yeah.
That's a personal point. I can't go to you and say, why didn't you vote? However, I could go back to my boss and I say, I'll tell you why he didn't vote. He had diarrhea and couldn't get out of the house.
I wouldn't have put it like that, but yeah, that may have been the factor.
That's a terrible answer. But I used to get that all the time. We had an exec that was real good.
Yeah?
And, 1949, USS Carpenter was commissioned. And I can tell you, the skipper, his name was J.B. Grady. We had J.B. Grady was the captain. Navigator was DeBenner. Navy Lieutenant Commander DeBenner was the navigator. We also had a J.B. Grady as an enlisted man, and J.B. Grady was the skipper of the ship. And the two of them he'd come up on the by the helmsman or something like that, and he'd say, Cornell, he'd request permission to talk to me a minute. And the skipper used to say, hi, JB. He'd say, hi, JB, Captain, sir. All this. And I says, and the skipper used to say, this is not a military greeting, this is a friendship greeting, JB to JB. Anyways, we're out. We're in Guantanamo Bay, Cuba. We've been on a shakedown cruise. Mind you, the skipper was J.B. Grady and DeBenner, and I'm on the deck force at the time. I'm not even in the signaling part of it because that came later. And myself and J.B., who was another seaman, we were up and we was on the forecastle, and we're up there chipping paint on the, we was on a boatswain chair and we're chipping paint and doing some things up there. And JB, he looked at me, he said, damn, it's hot up here. And I said, yeah. You thinking what I am? And JB says, let's do it. We took our paint can, a little can of paint, a little quart can that we were painting with. We set it up on the deck. I took mine, I'm on the other side and set that. And I said, you ready? He said, let's do it. And we jumped off the scaffold and went in the water. And as soon as we got in the water, I said, look up there. Who was standing up on the bridge but the skipper, just watching, and he looked at us, and I says, oh, we're in deep trouble now. And he went like this. and turned around and walked away. And later we come up and he says, "How was the swim in the water?" He said, "How was it?" We said, we were shocked. We figured we're going to be disciplined. He thought it was the greatest thing, you know. And here's these two guys that decide in Guantanamo Bay they're going to go for a swim. They put the paint cans up there, and it looked like the scaffold went from under us and kicked that, and when we went down in the water. He saw the whole thing, and he just went like this. But when we come up on the bridge, he said, "JB, how was the water? How was it?" And he says, well, things like Navy talk. He says, "Cornell, you got balls that big to do something like this." He says, "And I'm up there watching you. You're not very observant, are you?" Well, we didn't know you was up there on the bridge. See? You got to know what your surroundings, and if you're going to do something like that, make sure nobody's around that's got a camera or going to witness it, you know?
Yeah.
So, yeah, things like that was good. Something to talk about later about when you went for a swim in Cuba, Guantanamo Bay.
All right. Is this print too small?
No, I can read it.
You want to read the book? I printed these up from our computer because it was on the... I could let you read that one. I'm finished with that one. I've got 4 booklets. I'm working on the 4th one now.
Yeah.
Oh, I just finished the section. I haven't finished with the booklet.
Okay.
Yeah. Why don't we leave that one? That'll be fun.
Okay.
All right. I'll put it over here. So we did the moon, but we didn't plot it, did we?
No.
So now let's see. Where is that moon? It won't fit on this because that's too big. Where is that moon? Well, we said the moon was 5.3. We come back here, 5.3. Where is it? Right in there. So there's 5.5. So maybe about there. So the moon, again, from the Earth's perspective, which it is now the center of the moon's rotation. So the moon, M-O-O-N, with the Earth at the center. This is from Bob Krellin, 2009, www. Bob Krellin, patent pending. Approximate distance between the Earth and the Sun, 93 million miles. And this is the Earth, the center. And he's got all these moons around the outside. I took my hole punch and punched it so it could hang from any position of the moon.
Mm-hmm.
So as the Earth spun and the apparent motion of the sun around the Earth, then you could see the moon in whatever position it was. So we said the moon is going to be here and the sun is here, so it's almost a right angle. We would expect the Earth is here and the moon is here and the sun is there. Then we line it up. So here's the Earth, here's the sun, here's the moon. Here's the Earth, here's the sun, here's the moon. So we're going to expect that the moon is going to be in the first quarter.
Mm-hmm.
Let's see. Here's the phase of the moon. Again, U.S. Naval Observatory. Astronomical Applications Department. It's the 17th of August. We'll look down here. August 21st. Nope. August 14th. Not bad. It says the last quarter. How did I get this wrong? So maybe what this is it's like this. So here's the Earth, here's the Sun, and here's the Moon.
Mm-hmm.
On mine, it's backwards. It's like from the other side.
Okay.
Looking through, instead of this way, we're looking this way. Ha!
Mm-hmm.
Which, you know, I didn't know that. That's kind of counterintuitive. So anyways, it is the last quarter. So at least we have the map here to tell us when's the moon new on the 21st at 11:30 local time. I adjusted this. I think I adjusted this. I did. Standard time, Pacific Standard Time. The gray is Pacific Daylight Time, and the other one is Standard Time. So this is the height of the eclipse. It's going to be 11:30 a.m. because when this gets around here, the moon is going to line up with the sun. It's going to do the eclipse across the United States.
Mm-hmm.
But we're only here now. Last quarter. So that's pretty cool.
Yeah.
I mean, it's not exact, like I said, it was backwards. But we'd use the charts to make sure we got everything straight. So that was 14, 15, 16, 17. Actually, a little bit more.
You? You want more?
No, give John one.
I'm okay.
I'm,
I'm all right. We had the melon. That was juicy.
yeah.
So waning crescent for the 17th. 18th, 19th, 20, 21. 21, 20, 19, 18, 17. Yeah. That's about where we are. Waxing, waning crescent. So, the Navy's been good to me, using their charts and things.
Mm-hmm.
And these are fun little toys. I got this at the Planetarium out in North Las Vegas.
Mm-hmm.
They're going to have an all-day event with the eclipse. I don't know. They'll probably see things from where they're looking at, and then they might have feeds or something that they can see from.
Have you ever been by the Hydrographic Office on Nimitz Highway?
Not
I
yet.
guess it's still there.
I should look it up.
I'm wondering if it's still there on Nimitz Highway, Branch Hydrographic Office. And
Let's see what we can find. That's for you. You can put that over there with your reading material.
okay.
I don't know where my phone is. My pocket. Is it in my pocket? It's right here. All right, so let's see.
Branch Hydrographic Office.
Nimitz Highway. Branch. Branch.
Hydro, H-Y-D-R-O. Hydro, probably.
Hydrographic Office. Nimitz. N-I. Nim.
엄마가 매수된 거는 나는 눈이 아버지하고 결혼했어요. 와서 몰랐지만 내가 흑인 애도 없고 한국에도 없고 나는 거기가 없다. 그러니까
Now it was, if it's still there, it's about halfway between the base and
The Naval Oceanic Office, 1962.
유달리 걔네들이 정확히 한국 사람하고 안 맞을 지인이 센가 봐. 흑인 세가 가는가 봐. 그래가지고
you might find me on there.
U.S. Naval Observatory and Hydrographic Office, 1854 it was formed.
Yeah.
It's not coming up here. Where's my map? Get to Hawaii. Now we're flying from here to Hawaii. We landed in Hawaii. We're going to go to Honolulu now.
Mm-hmm.
We're going to look for Nimitz. Nimitz Highway. Well, there's Nimitz Road.
Nimitz is named after Admiral Nimitz, I believe.
Yeah, there's a ship after it too, isn't there?
Yeah.
USS Nimitz. Well, the highway should be this 18A. U.S. Marine Golf Course, Navy Marine Golf Course.
Yeah.
Nimitz Highway.
There you go.
There's Joint Base Pearl Harbor Hickam. We can't find. Send us back to Washington, D.C.
Mhm.
And they got terrible traffic problems. So I don't find it in Honolulu anymore.
It was a branch office, so branch hydrographic office. And we had a retired Kylie.
Yeah, I remember his name.
Kylie? Have you ever picked up?
But you talked about him.
It was something else. And Chambliss was the hydrographer that came out there from Honolulu, from Washington, D.C., and he ran the office as far as civilian goes. And we had a W.W. Havens, who was the Navy commander in charge. But Kylie, or Chambliss, had a parakeet. Did I tell you about that? Had a vocabulary that was out of sort. He'd say, "Hello, good morning. My name is Digger. I am a fantastic or hilarious bird." And then we'd say, somebody would say, "Well, this is Admiral so-and-so. They used to come from the base, and they used to come in the office just to see that bird." And one of us would take him over and said, "Would you like to hold him?" And he'd hold him, and he'd say, "Hello, Admiral. Kiss me, you fathead." And everyone laughed like crazy in his party. He might have some colonel or general with him, and they would laugh and say, "My God, this bird." And "My name is Digger. Kiss me, you fathead," said the Admiral. What else did Digger used to do? Oh, he had a dog. Digger was a bird. I can't think of the name of the dog. He'd whistle. He'd actually, he'd say, "This is Digger." I can't remember the name. He'd say, "Come give me a ride." And the dog would run over and he would jump on. And then Chambliss used to say, "Where do you want to go?" "I want to give the Admiral a kiss." And all kinds of crazy things. Can you imagine? Anyways, Branch Hydrographic Office. You say it doesn't show up.
No.
Probably by now it's long gone. If you say Hydrographic Office, I could see where it's gonna take you back to DC because that's a hydrographic office. But if you say Branch Hydrographic Office,
I'm on the Queens Freeway here.
Queens,
Nimitz.
Nimitz. It was on Nimitz Highway.
Do you know the cross street?
The Navy,
Well, here's the rental cars. We rented a car from there when we went to Honolulu in 2008.
mm-hmm.
Do you know it was on the north side of the freeway, or on the highway, or the south side?
South side.
I don't know if they had the golf course by then.
You found the golf course?
There's a Navy Marine golf course. Then there's the base, Joint Base Pearl Harbor, Hickam.
Hickam, yeah. Okay. You go from the Hickam, the base,
Yeah,
and go down Nimitz Highway towards Honolulu.
toward Honolulu.
Yeah. And
It's on the south side.
south side.
I wonder if that's it. 'Cause that looks kind of like the pictures. It says it's St. George's Episcopal Church.
No.
You can turn it around. Don't see here. There's a sign. Hawaiian Telecom. Well, that's Hawaiian Telecom. From the pictures, it looks like a small building. Those look pretty neat. Fleet Reserve Association Branch 46. Here's the freeway. This is the airport. I don't imagine the airport was there. Was it very far from the Hickam?
About 1 mile from Hickam. No, here's Pearl Harbor,
Yeah,
and here's Nimitz Highway.
yeah.
If you're leaving the base at Pearl Harbor, you're on Nimitz Highway, and you come down here. Let's see. Come down here. Schofield Barracks was right up in here. Navy. The Navy Commissary was over here. Hickam Air Force Base was right up here. You come out of Pearl Harbor, you hit Hickam Air Force Base, Navy. I don't
That's-
know. I'm sorry.
It's hard to do it on that cracks there.
Yeah.
Well,
But if you had, if you can pick up 1962 and get Branch Hydrographic Office,
yeah.
I think it would show it. What was that?
Sounds like a phone.
Yeah, it's her phone. There it is. Where are you, Yamo?
The 1962 map of Pearl Harbor. Well, that's a December 1941 map.
Oh.
Pearl Harbor historic sites.
Does this say Fort Island?
Yeah.
Okay.
It's the visitor center. Well, they got 1941 maps, but not 1962 maps. I'll keep looking.
Mm-hmm.
I'm sure.
19.
62 map of Pearl Harbor, but it doesn't. It said, oh, you got the date wrong. You want 1941. Everything
Oh.
happened in 1941. All right. Let's take a break.
Yeah. Here. eat this. I can't eat both of them. You have 'em.
All right. Still working? Up, battery's dead.